Yeah,
Okay.
so we're probably just starting the recording now.
I have
Um,
a feeling we are.
yeah,
It does
so
look
if you don't have one, you get a nastygram. So,
okay. Well, we'll have some of the recording.
okay, so let's take a look at that the end of that motor.
Yes, the motor. So this isn't the exact motor casing, but it's just a 1 grain 98. So we don't have to get the 6 grain XL out.
Okay.
So we have our 98 millimeter forward enclosure with our 316 3/8 eye bolt. I can't see it through the camera. Yeah.
Okay, and so that's going to be your recovery attachment point. And the next question is how are you going to keep it from unscrewing?
Cotter pin?
I want to.
You want to? Okay.
Is it? We can ask if it's
Yeah.
less red.
Do you have any suggestions on that?
Well, since I mean you're just going to have, I mean there's no coupler around the motor. You're just going to have the end of the motor coming up through the tube, so you don't really have anything. I mean a common way to keep those things from unscrewing is if there was a second hard point nearby. You I mean you could probably even figure out how to do it on the closure on the motors, but the idea is that you'd have like a second eye bolt of some sort, and then you might take some safety wire or some Kevlar thread and wrap it around both of those eye bolts. That way you can't unscrew it. It would be something that you would do on an altimeter bay, for example, if you were using eye bolts or eye nuts at that location. You'd have a second attachment point, and then you would use a loop of Kevlar thread so that it can't unscrew. With what you've got, the wrong way to do it would be to try to use some sort of a lock nut or something, and then screw that down into the stem of the motor,
Yep.
because that's not the intended way that those fittings should be used. A possible way to do it would be to use lock thread of some sort, or
Okay.
thread locker of some sort. I personally don't like to do that, although I know a lot of people do. I just like to be able to remove stuff and keep it from getting conked up. What I would do with that situation is I would use a cotter pin.
Yes.
Well, my recovery lead wanted to hear a cotter pin.
Yeah.
He likes those.
That's not
Yeah.
considered an infrared motor modification?
No.
Okay, awesome. We're doing cotter pin.
All right.
Now,
Yeah.
now the trick to it is though the cotter pin has to be installed down near where the beginning of the stem is. So not near the eye bolt, but further down.
At the bottom.
Gonna
Yep.
be
Yeah,
down
like
there.
right down there.
So you're not stressing the hole as much.
Well, you don't want to, how shall I say? If you do it up at the top and it fractures, it just
Yep.
immediately comes out. I mean,
Right.
you're trying to retain the strength of the thread and the section that it's being threaded into, and so you just want to be down in the lower third of that section. And it's a pain in the butt trying to figure out how to drill on that stem. One way to do it is you just file a little flat spot, and
Yep.
then you should be able to get through it.
All right. Cool.
That's not S-Rad. We're doing that.
Yeah. Yeah. We'll definitely do a cotter pin.
Yeah.
Okay, so I think all the attachment points are good. On the drogue harness lengths.
Yes. I don't know those off the top of my head, but they should be in here. Everything's around the high end of 20 to 30 feet long. Yeah, so here's another 39 section we'll be using.
Yeah, you might, I personally would use at least 30 feet.
Yep.
You will find reviewers though that will want more than that. And it's like, well, okay, you know, there's never anything wrong with a longer drogue harness. And I have one reviewer that I was on a call with yesterday that wanted 5 times the length of the rocket, whatever that is. So,
Okay.
you know, it's kind of a rule of thumb. So, you know, I would, if you've got something in the 39 to 40 foot range, you know, that would be a good spot. That would
Perfect.
be a
Yeah,
good
I
length
believe all
for
of our
the-
shock cord is around that length. After the, I want to say second progress report, I think you commented on the drogue harness length, and I do remember making that change to something longer.
Yeah, I think you had 20 feet at the time, and that's not long enough.
Yes. Yeah.
But you know, I would say more than 30, but there are reviewers you'll run into that would say longer than 40, and they'd make you go buy another shock cord. So you're better off just to head that off before you get there.
Yep. Yeah, we'll be up in the upper 30s most likely. So
Okay, and you'll have the drogue biased one direction or the other on that drogue harness.
yep, yeah. On this one, you can see right in the middle of the shock cord, there's a loop where it'll be, it's 1/3 from the, in the case of the booster, 1/3 down from the transition or the body tube above it.
Okay. Yeah, with the use of a knot, the other statistic that you need to be able to provide is the derating of the strength of the harness as a result of that knot.
Okay.
So you can Google that and you can find out for the kind of knot you have, how much it derates the. You're better off not to have knots. You know, my personal opinion is knots are okay as long as the underlying harness, you know, if you've got a 7,000 pound harness and you derate it 20%, you know, you got a 5,000 pound harness. It's like, that's pretty good.
Yeah.
But if you have a, you know, a 2,200 pound harness and you derate it 30%, now you're starting to get pretty marginal.
Yep.
So, you know, I would check that number. And I would say for your rocket, I mean, you should probably retain at least 3,000 pounds.
Okay. Yeah, we'll add that
as
onto
sort of
the
a criteria.
Yep, we'll check that out along with
Yeah,
the drogue
'cause
side.
I can guarantee you that, you know, as soon as the knot is spotted, that'll be the next question.
Okay, perfect. I'm glad we know that ahead of time.
Yeah. Okay, so tell me a little bit about how you are going to use the deployment bag.
Yes, so our deployment bag, I'm going to use this one as an example. We have our pilot chute point there. Inside of it is its line. So this line was connected to the attachment point on the top of both of the top of the orange and black parachute, and then shoved into here. So all of that shock cord then was left outside, wrapped around the elastic, and then when it came time for flight, the pilot chute pulled it out, shock cord pulled the main out, and then the bag stayed connected but above the main chute because of this point here from the fruity chute bag.
Okay, and you are well, one thing, as long as I'm thinking about it, kind of a good thing to do is to perhaps extend the line from the pilot chute to the bag just by a foot or so.
Okay.
So that you have enough room there so that even if the bag doesn't come out for some reason, the pilot will fall out because it'll have a little extra line. And, you know, if it gets outside the airframe, then you'll be okay.
Okay.
But it's cheap insurance.
Yep.
And so let's see. So you're going to have the shroud lines attached to that harness somewhere. Where's that going to be at?
Shroud lines attached to the harness. Yes. This is our parachute. I don't know where that point is because it's all folded up. But there's a singular point that it comes down to very similar to this one from Fruity Shoots, and so they're all quick link here.
Okay, and that'll be to another knotted point on the harness.
That will be to a knotted point on the shock cord.
Okay. Okay, so with the I just would like to give you an idea for a good spot to attach that chute. It may not make a whole lot of difference because you're using CO2. And so, you know, it's not like you're going to jettison the cone at, you know, some super high velocity. It's just going to kind of get pushed off.
Yep.
So I think in that situation, I probably would be okay with putting the chute closer to the nose cone rather than the body tube.
Okay.
The thing I always worry about, you know, with the deployment method like what you're doing is where is the chute going to open? And is it going to be upside down or right side up? And is it going to be far enough away from the rest of the rocket so it doesn't follow?
Yep.
And so I look at the recovery, you know, I'm trying to envision how it's going to happen. And, you know, if the nose cone is not going away at super high velocity, then the pilot chute is probably going to be able to rise a little bit before the nose cone pulls tension. And so that should be okay. Yeah. So, okay. So I think that's fine.
All right.
Okay. Let's see. Let's talk about the N5800 for a moment.
All right.
Have you put one of those guys together?
I personally have not, no.
Okay. I'll just give you fair warning that that's a difficult motor to assemble.
Okay.
And one reason for that is because they close the end of the tube, so all of the grains have to come in from one end. And if you follow the directions as they're currently written, you still have about a 25% chance of a failure where you lose the motor.
Okay.
And the thing that happens to you is, you know, you know, if you're using the most commonly used glue, which is the amber Gorilla Glue. You know, at some point in time, you know, I mean, you put glue on a grain and you push it in part way, and then you put a spacer in there, and then you glue the next grain and push the two grains, you know, a little further in, and so on and so on. And by the time you get to that fifth and sixth grain, the glue's starting to set up.
Ah, okay.
And I could share nightmare stories where me and a couple buddies are leaning on that motor as hard as we can to get those grains in. It, you know, they used to tell you to wet the grains a little, but if you did that, you had no chance. You couldn't assemble the motor. So, you know, a couple things, three things maybe to think about. Now, do you have the motor yet?
Yes, we have the motor.
Okay. You probably wouldn't be allowed to do this, but if I was doing it, I would assemble the motor ahead of time.
Yes.
And you have a long way to drive with a motor if you do that. But I like to do that under controlled conditions.
Yes. I remember the alumni from when they went to spaceport were saying, because they also flew an N5800, they said that there was somebody hosted an event to help everybody assemble their motors, and that's how they did it.
That was my next suggestion. They will probably do the same thing.
Okay.
You'll probably be wild man. We'll do that and go over to the hotel room and take the motor and do it there.
Okay.
But it's still difficult, even
Yeah.
if you're doing it under his supervision, because the glue sets up. And,
Right.
and you know, you have there's a couple of ways to mitigate that. And one is just to have an assembly line process ready to go. You know, so that you know, someone is putting the glue on there and stuffing it in the end, and someone is cleaning up the glue as it drips off the grains, and someone
Mhm.
is putting in the spacer when someone is gluing the next grain, so that you can literally do the whole thing in about 10 minutes. And,
Okay.
and if,
Yeah.
if you're able to do that, you shouldn't have problems. The way I do an N5800 is I you know, I'll take the grain, and then, you know, they have the little spacers between each
Yep.
grain.
Yep.
And what I'll do is I'll take just a tiny little bead of epoxy and I'll put it around the edge of the grain. You know, not around the cylindrical part, but just around the circular part. And, you know, so that I can set the spacer on there and glue the spacer to the grain.
Okay.
And what I'll do is I'll take a piece of Mylar and I'll wrap it around the grain so that the entire spacer is inside the perimeter of the grain.
Hmm.
Now I got 5 of the 6 grains have spacers on them. And now I can glue the grain and I can push it all the way to the bottom of the tube. And then I do the second grain and put glue on that, and I can push it all the way to the bottom of the tube because the spacer is glued to the grain.
Yep.
Okay, if the spacer's loose, you can't do that.
Right.
And so if you do that, it takes a very stressful process of making a motor and reduces it to a piece of cake.
Okay. Cool.
Because each grain is put in separately and you're not pushing all of the grains toward the end of the process.
Yeah.
You're only pushing one at a time. And
Yeah,
I
I
put
like
together 20 of those things, and I sure like it a lot better when I do it that way. Because there's no stress.
Yeah.
So those are sort of the alternatives, but watch out, like I say, because it's a difficult motor to assemble. The other thing that I'll just pass along with that motor assembly is that, you know, with a lot of these motors, the CTI motors that have conventional nozzles, once you can put the nozzle in part way to where the O-ring is at the end of the threads. And now you've got to get it in past the threads and down into the case. And you can use the threaded forward closure to literally push the nozzle in.
Yeah.
With the N5800, you can't do that. It's got the XL nozzle size. So you're not able to use the threaded ring to put it on there. So you have to figure out how to push the nozzle in and to keep it straight while you're doing that. And if you don't do that, it's very easy to shear the O-ring as you try to put it into the case. So the secret is to have the, let's see, what is the secret? Oh yeah, the secret. I mean, once you get the grains in, a good thing to do is to make sure that the nozzle itself is glued in. And you know, you don't necessarily want to put 100% glue around the rim of the nozzle, but you might put glue in 3 or 4 places so that it stays into the liner. Okay,
Mhm.
you want to leave a gap in there so pressure can come out or in if it has to, but you have enough glue on there so the nozzle stays inside the liner. And then what you do is you stand the motor up on the nozzle and you bring the case down over the top.
Okay.
And that keeps everything aligned as you're bringing it down, and it allows you to apply some force to it. What you don't want to do is push on the nozzle to get it into the case, because now the nozzle can get cockeyed, and you know, you've got no real way to do it. I've seen people try to use hammers to get the nozzle into the case, and they lose a lot of motors when you do that. So the secret is stand it on the nozzle, You don't have to glue the nozzle in. It just helps kind of stabilize it a little bit. And then now you can pull the case down over the top of the liner and over the top of the nozzle.
Okay.
You do those two things with that and with the O-rings, and the motor's easy to assemble. Otherwise, it's very difficult.
Perfect. Yeah, I'll keep those in mind.
Did you have any other test flights planned or anything, or what's
No.
yet to happen?
So unfortunately, our test flight as a boosted dart won't be able to happen as I didn't get funding from the university until about halfway through the spring semester. And so it pushed my plan back about a month. And so we're still trying to recover from that incident. And so we're not going to be able to test fly as a boosted dart. So the booster won't have a flight, but the sustainer still has had it.
Okay. Have you determined yet what your final stabilities are likely to be?
I can pull up the open rocket real quick and see what it says. Once the booster's done here, I expect that number to change since it's right now just what weight open rocket is saying. And we'll have the
Which
actual
is never a good way to do it.
yeah, we'll have the actual weight, and then we'll be able to determine it much better than we can currently.
Okay. Well, hopefully, I mean, a good target range for the stack is 2 to 3 calibers. And a good target range for your sustainer is probably 2 calibers.
Okay. Yeah, let me pull up a graph here. And we'll take a look. So it looks like as a stack, we're going to be leaving the rail with about 4 calipers. This booster will have, or as a stack, it goes up to almost 9. And then at stage separation, the sustainer carries with around 6 while booster falls.
Okay, it's 6 to begin with
It's
on the
4.
sustainer.
Uh,
That looks like it's maybe without the motor.
that I believe is with the motor in it.
Is this a plot of the stability throughout the flight, or just
Yes,
the stability at like Mach 0.3, the standard open rocket stability?
at over the course of a flight.
Okay.
Okay, are you showing your screen?
I can if you give me
Sure.
1 second. Okay, I think you can see it.
Yeah. Okay, so you're starting out 4 on the stack.
Yep.
And yeah, and then the sustainer starting at 6. That's awfully high. Why is that so high?
I am not sure.
Okay, close that particular graph. Yeah, something is not correct
Okay.
here. You should, with the way that you have things set up and the payload being in the middle of the rocket instead of in the top. I'm thinking that you don't have the right stability yet for whatever reason.
Okay. Let me make sure this doesn't. So this right now has. Yeah, this is a nose cone weight right now. So that would increase it, and then I believe, yeah, payload's still set at 9 pounds. So
Yeah, I mean, you typically see stability numbers like that when the payload is up at the top of the rocket.
Yep.
When it's in the middle, usually, I tell people put it in the middle so you don't have, really high stabilities like that. But
Yeah.
I think you've got something in there that is not measured in the correct way, because I just don't see how it would get that high with a smaller motor up there. Your fin span is not huge. Payloads in the middle. I mean, something is not correct. So I would recommend that you try to resolve that.
Okay.
As quickly as you can, so that you can hit the right stabilities.
Yeah, we'll take a look into that.
If you do find that your stack is very overstable, one thing you can do is just try to separate the stages a little more quickly.
Yep. Yeah, I think right now so burnout and then 6 seconds is when stage separation will happen. So we can definitely.
Yeah, and that's probably what you don't want to do. I mean, unless the sustainer was more overstable than the stack at that point.
Okay.
But like I say, I have a feeling it's not really that way. What are you going to do for the igniter?
The igniter. You want to explain that?
For the sustainer.
So we have a wire run. I'm gonna grab my. Can we show that?
Yeah. Yeah, you can try and show that.
Grab the rocket.
Yes.
So we have a wire run. Nick, can you stop sharing the screen so I can see where the camera is?
Yes. Also, we have 8 minutes left until it's going to kick us out again, so we'll have to.
Yeah, we probably have one more session yet before we're done.
Oh, there we go. What would be the easiest way to see that?
I don't know if you're going to be able to see it,
Okay,
but you can try. You can try.
Yeah. So we have another wire run, that same carbon fiber tube that Nick showed you earlier. There's
Right.
one going down. What did you say? Can you repeat what you said?
I just said right. Yeah.
Okay, sorry. So there's another carbon fiber tube running down the length that exits. Not exactly sure which side. Right there. I'm not sure if you can see it in there. No, we're not gonna be able to see that. But it exits, comes down the length of the coupler, and then it's gonna bend and go back up into the motor. Your recommendation for the switch in between, so we can power on the bay separately from the igniter, we have taken, and we're going to be following that process.
Okay. Yeah. You have to have a switch to isolate the igniter. That's a rule.
Yep. Yeah, we have that switch on. We're going to be following your process of testing the igniter outside of the bay first, outside
Okay.
onto the stack, and then connecting it to the correct igniter.
Okay. Can you hear that hammering? I'm just curious.
Yeah, that's the construction in the bathroom.
No, I mean the high hammering I have here.
Oh,
All right, so
we don't hear that.
Really? Okay, well, that's good. Okay, so you're going to have wires coming out of that conduit, and then you're going to attach your igniter to that, right?
that is correct. Yep.
And one little trick I'll just pass on to you. I assume that you're using a stick to support your igniter.
Yep, some kind of a cardboard tube or something. Yes.
Or
A thin dowel.
1/8 inch dowel or something.
Yeah, we have a bunch of dowel rods that it'll probably end up using.
Something like that.
Yeah, one trick you can use is that if you're gonna tape your igniter to the top of the stick, and then you would probably tape wire to the stick at a couple places.
Mm-hmm.
Only tape it halfway down the stick. If you do that, you can pull the igniter out of the motor and put it back in.
I see. I can understand that. Yep.
And it's a little bit of an optical illusion, but it works. That way you don't have to leave a lot of excess wire to be able to put the igniter in and out of the motor. So you can actually have it immediately come out of the conduit and then bend right up into the motor. But if you only take it halfway down the stick, you can still pull the igniter out.
Makes sense.
The trick to getting a sustainer motor is to prevent the stick from being ejected from the motor when the igniter fires. And it's not as simple as it sounds, because you have to figure out how to hold the stick in, but still allow enough room for the igniter gases to leave the motor. Okay, if you just tape the whole motor shut with the stick, it'll just blow that tape off and the stick with it. So
Could you, for that, the red cap that usually comes with it, could you just put that on and use that to hold it in place?
nope, because as soon as that red cap gets blown out, the igniter will get blown out with it.
Okay.
So there's some different ways that you can do it. I mean, you can imagine maybe taking a couple inch long piece of electrical tape, for example, and putting that over the end of the stick, and then putting the electrical tape on either side of the nozzle, so that the electrical tape is holding the stick in, but it's not making a gas seal that covers the whole nozzle.
Okay.
Does that make sense?
Yeah.
The way I do it is I take some very thin Kevlar string or nylon string, like kite string.
Yeah.
And I glue that inside the motor somewhere, like on the grain or on the inside of the nozzle.
Okay.
And then the string hangs out the nozzle itself. And then when I load up the igniter, I wrap the string around the end of the stick and super glue it.
Yeah.
And that string holds the igniter inside the motor just long enough to where the motor will light.
Okay.
Because if you don't do that, you're about 50-50 for lighting a sustainer. The secret is keeping the stick in the motor.
Okay.
And so, you want to, affix the stick so that it stays in. And then you can use the red cap to keep, if you're using black powder for a separation charge, you'd want to have that cap on there to prevent that charge from getting up into the core of the motor.
Right.
With CO2, I'm not sure if it matters all that much, but I would use it. I would put the cap on there and push on the cap and not the core. But the idea is to not be able to have the stick get spit out when that igniter fires.
Okay.
So I sent you a description of the programming for the altimeter.
Yes,
Did you?
I remember that. Yep.
Yeah, take a look at that. I don't know if you have or if you have any questions about that process.
I don't think I have any. Nope. I think we're good.
Okay, or have you looked at it enough to where you can say, yes, I know that's how we're going to do it, and I don't have any questions?
Yes, that is correct. Yes.
Okay, all right. Yeah, I'm fairly prescriptive on the program for that, because I want to make sure that what doesn't happen is that, something happens where the rocket coasts up to apogee and just barely triggers the igniter and the thing turns upside down, down it comes. So there's some things that can happen with different programs. So if, at some point in time, we'll look over that program and you can show me exactly, where is burnout, where is separation, where are you lighting the igniter, where do you expect it to come up to pressure, and then where does your altitude check do its check in that scheme.
All right. We have less than a minute before this call ends, like the last one. So before we head on to the next part, we'll have to rejoin again.
Why don't we just do that? Is it the same link again?
Yes, it should be.
Okay, I'll wait a few seconds.
I don't have a wireless webcam, sorry.
Okay. It's converting that meeting. David will be back shortly. All right. I mean, we're just waiting for our Flyhard record to join back and we should be good to go.
Yeah, I forgot to ask about that. Who's the flyer of record?
David Vestal. He was
Okay, yeah, okay. Yeah, I'm not sure I have all that much more to go over.
perfect.
I'm just gonna look down my list here. Oh, one thing what was your payload, again?
So about
Bag of rocks?
24 hours ago, I got told that my payload won't be happening. So we are back to the drawing board and we're going to try and find something to put in there. The payload of the rocket that went to spaceport for us 2 years ago, we're looking at revisiting that idea just because we have all the materials still for it and could continue that test.
Okay. Yeah, one thing, that will be looked at on the payload, whatever it is just to make sure that it can't move.
Yes.
If it's a non-deployed payload, you don't want it moving around. And so you'll want to be able to demonstrate that that doesn't happen.
Yes, and I can explain that. So, assuming if we repeat what the last rocket did, Trevor, can you grab that aluminum stuff? So, inside of the payload coupler, which is built similar to our avionics base coupler, we'll have all of this aluminum, and that will house the entire thing. And a threaded rod goes through the entire center of it. And so, this is basically going to be held inside of that fiberglass coupler and not be able to go anywhere.
And that has AVE lids on either end of that coupler as well.
Yes.
And the last thing I had on my list was an 18-inch pilot. Don't want to use the 18-inch pilot.
Okay.
Want to be fine. Even if the vendor says that, don't believe them. You want to use a pilot that's large enough that you're guaranteed to get it out.
Yes. Yeah, we'll look into that.
A larger pilot doesn't hurt. It makes the pilot and the deployment bag stay above the main chute, and there's absolutely no reason not to use a pilot that's large enough to make sure that the chute gets pulled out.
Okay.
Couple notes on the event. I have written this stuff down, but I'll just say it again. Do anything and everything you can to be able to launch early in the morning.
Mm-hmm.
It's my understanding, and I haven't heard any details of this, but it's my understanding that they may let members of the two-stage team and the hybrid team stay out at spaceport overnight.
Okay.
And that can be a really good thing because the last couple of years, it's just been a cluster getting into the parking lot area on the first day. It's like an hour or two delay. The mornings seem to back up. So just when you're trying to get there to fly your rocket early before the wind comes up, they've got a traffic jam, and you can't get in. So if they do that, it would be a good idea to have someone that's out there and can start the process of getting things assembled, because typically what happens is that the wind will start coming up around noontime.
Mm-hmm.
And there was a problem last year because the wind came up and it got too high to fly. along around noontime. And so, I mean, they ended up launching rockets and they caught a bunch of heat from it, from Tripoli and from Spaceport, because they had rockets weathercocking and, it was not good. And so they won't be doing that this year. So that means that, that you need to be able to launch in the morning, along with everyone else who's going to be trying to launch in the morning. So it's a little easier on the two-stage pads because, once you're close to being ready, you can come out there to do your final preparations, as opposed to the single stage flights where, everyone has to go out and immediately set up and then leave. At the two-stage pad, you can sit out there for a little while. More so than the single stage pad. So you've got a little bit of opportunity to get things done, right before the launch. But man, you just need to be able to figure out a schedule that where you're sitting on that pad ready to go by 8 in the morning.
Yep.
And if you don't do that, then you're going to run into other teams that are going to be trying to launch, and you're going to run into the wind. And this year, I'm not pushing the button if we're over about 15 miles an hour. I'm just not going to do it. We launched rockets at 25 miles an hour last year, and they were going everywhere. And we're just not going to do it.
Okay.
And it's not going to be allowed anyway. And, but for the two-stage pad, my criteria is probably going to be a little greater than for the single stage pad.
Yeah.
We're just not going to launch these things when the wind is blowing. So you have to, I always ask the team, so when are you planning to fly? And they say, oh, we're going to be on the pad by 7 o'clock on the first day. And after doing this for 6 years or so, there's never been a rocket out on the pad at, 7 in the morning on the first day. Teams are out there trying to figure out how to make stuff work, 3 in the afternoon after they told me they were launching first thing in the morning. And so if that's what you end up doing, then you're likely to have problems being able to fly.
Yep.
And so, if you think about it and practice a little bit and make sure that you're organized, you can do it early in the morning. I mean, I launch a lot of two-stage rockets, and I go out and I'm 4 in the morning, I'm setting the things up, and I'm usually hitting the button by 9 or 10 in the morning. So, by myself. So, I know that it can be done, and I know that teams can do it. So I just strongly recommend that you put a great deal of emphasis on figuring out how to make sure you've got everything, and that, it always works out. Well, we can't launch because Joe's got the altimeter and Joe's stuck in Las Cruces, and, stuff like that happens with the distribution of responsibilities that ends up preventing you from being able to fly.
Yep.
So, pay as much attention to that as anything else you're doing, because this year it's going to be very important.
Okay. Yeah.
Be a lot of visibility on that aspect of it this year. There was the guy who's the RSO probably spent 200 hours doing dispersion diagrams with the wind, trying to
I'm on a
convince,
vehicle.
trying to convince Spaceport to let us launch rockets there. Because rockets are going everywhere and they don't want that. And so there has been a lot of effort trying to assure the Spaceport folks that we can do this event without having rockets land on the crowd.
Yep.
And that means not launching in the wind. And we just have to do it that way. So just trust me on this. Do everything you can to try to figure out how to organize your schedule and organize your team and organize your time, so that you're ready to go as early in the morning as you possibly can be.
Yep. Yeah. My advisors gave me a similar word of advice as well. And so we kind of thought through what we're going to do, and I'm going to work on planning it to the days leading up. So we have a battle plan going in. We'll be good.
Yep. That's real important. I guess I don't have anything else. Unless you have any questions.
I'm good. I do have one. Since we didn't record the first half where we went over the airframe, is that fine?
It is what it is.
Okay.
I think the Spaceport folks want to receive a link from you not a YouTube video, but an actual link to a drive.
Yep.
And then they'll post it somewhere. And my guess is no one will watch it. But they might.
Okay.
You know, you just have to have something there. And, you know, you might explain that we forgot to turn on the record button for the first part, but Jim liked the airframe and so forth.
Yes.
But you get something to them, because if you don't get something to them, then you get a nasty gram.
But yeah, I don't want that.
No. Okay, well, I'm looking forward to watching the rocket fly.
Thank you.
Hopefully we'll have good weather and all that kind of stuff.
Yeah, we're excited. It should be a fun time.
Yeah, and you know, don't underestimate the heat. It's amazing how many teams come out and don't bring enough water. It's like you can, in that environment, you literally start drinking water at 8 in the morning. You don't stop
Yep.
for the whole day. And you know, so everyone's going to go through, you know, 8 bottles of water through the day. And if you don't bring enough, now you know, they'll have some they can give you, but just don't underestimate that part of it.
Yeah. Yeah, we're gonna bring 2 giant coolers full of water and ice, so it should be good.
Yeah. All right. Let me know if you have any questions between now and then, and otherwise we'll see you there.
All right, perfect. Thank you.
Okay, you're welcome.